Hi, this is Dima Brook, CTO of XP.network, and today we're going to talk about how to bridge NFTs from one blockchain to another so that they arrive to smart contracts with custom logic or custom collection name. Here you can see the repository of XP.network. We have 160 repositories hosted here, and the repository that you can be interested in is contract interfaces. Let's get there. Here you have the templates for the smart contracts and the code that will allow you to test whether you deployed the contracts correctly or not. You can start testing from testnets of a couple of blockchains. For example, you can select BNB and Polygon as the first blockchains you want to interact with. Here you have a step-by-step instruction how to test it and how to deploy the contracts. So let's actually follow this instruction and see how it works. So the first thing we have to do is we have to clone this repository onto your machine. Then let's go to the folder of this repository, like so, and let's run yarn to install all the dependencies required for those tests. In the meantime, while the dependencies are being installed, and in order not to lose time, we'll do the following. Here is the contracts folder with the smart contracts that we can use for the tests. And let's go to Remix. Let's delete the current environment that we had, and let's create a new one. And instead of default, let's choose the OpenZeppelin ERC721, because this is the type of contracts that we're going to interact with today. Okay, instead of sample contract, let's remove it. We're not going to need it. Okay, let's remove it like so. And let's get the contracts from our repository. So we can go here. This is the folder with the smart contracts. Okay, so we can create a folder called roles here. And like so, let's call it roles. And inside the roles repository, we'll create a smart contract also called roles. Roles.sol for solidity. And let's go to the roles smart contract. Let's get the raw version of this contract. Let's copy it and let's paste it here like so. We'll do the same. We'll do the same with a Minter contract, and we'll copy it to Remix. The question is why we are doing this. Minter.sol. Okay, so we are adding the Minter extension to our smart contracts in order to be able to give the Minter role to the bridge smart contract. When an NFT arrives to the target chain, our smart contract has to have the role of a minter to mint wrapped NFTs there. Our smart contract is not the owner of that contract, so it needs a specific role to be able to do so. We will also need to have this bridge NFT smart contract. This is an abstract contract. It doesn't implement anything. We should add it to the root folder here, like so. It's called bridge nft.sol. We are using this contract as an interface to verify that the contract that our bridge smart contract is interacting with has the following functions: minting, burning for, and it can return a base URI. These are the necessary functions that our contract interacts with, and if they're missing in the target contract, the transactions will fail anyway. So in order to save on gas for the users and for the projects, we check that the target contract meets those requirements, and only then we interact with that. Okay, the other things that we're going to need here in the contracts folder, Bridge NFT batch does the same, but for ERC 1155 type of contracts. We're not going to use it in this demonstration today, so we don't need this today, but we're going to need those two contracts, original contract example. So this example will be used. We will deploy this example on the chain of departure. Let's call it just original short. And let's paste the code here. Okay, original contract example. And we already have the variables that populate the constructor. We're calling ERC721 constructor. And we will call it original contract example. And the ticker of this token will be OCE for original contract example. All this contract does is it mints and burns NFTs. And we're not going to use burning today in this demonstration. We're going to mint an NFT to be able to test that everything works as expected. All the rest of the functionality is inherited from ERC721 URI storage contract. So we don't have to replicate it here. And it comes from OpenZeppelin, a very reliable source of validated smart contracts that we're using. And we're going to take the target example. And again, we're going to take the raw code of this example like so. And let's call it target for short, target, SOL. And let's put it here. Meantime, we can see that all the dependencies are installed and we're pretty much ready to go. Okay, so the first thing we'll have to do here, we will have to compile our smart contracts, and then we will deploy them here from Remix. Right now, we can see that our MetaMask is already set to BSC testnet, so we're good to go and deploy our first smart contract on BSC testnet. Let's select BSC testnet to be our chain of origin. So let's deploy the original smart contract. Okay, we'll go here. We will select the latest version of the compiler, and we will compile the contract like so. Okay, we see that there are no errors and no warnings. It means that we wrote the contract in a good manner. Now let's go and deploy the contract. We want to inject the account from the browser extension from MetaMask. And let's select the proper contract, which is called original contract example. We already provided all the necessary parameters by default in the contract code itself, so we don't have to provide anything here. We can just press deploy and sign this transaction in MetaMask. We'll have to wait a little bit since it's a transaction on a blockchain, and we can see that our transaction succeeded. And we have the address of this smart contract here. Let's see that, yes, the address is here. And we can interact with our smart contract right here. Okay, this is the original smart contract that we're going to use to mint NFTs and then send them to the target chain. We can mint an NFT right here in Remix, which will be quite visual, or we can do it from code. We have a special function for that. So probably let's try and do it from code, since anyway it's already there. But here what we can do is, just to be sure that this is our contract and everything's fine, we can try to get some values from the contract. For example, let's get its name, and it says original contract example. And let's look at its symbol, and it says OCE, exactly as we specified here. Let's see, the token ID is 0. We have 0 NFTs here at the moment. And there's pretty much nothing else we can check here right now. But we're going to need the address of this contract for further actions. Well, let's leave it like this. And let's deploy a second smart contract, but for that, let's change our network from BSC testnet to to Polygon testnet, which is called Mumbai, like so. And again, let's go to the smart contracts. And let's select our target smart contract. Let's compile it with the latest version of the compiler. Okay, the constructor type error, the constructor has, okay. Let's remove visibility from the constructor, like so. Okay, now we're good to go. And let's go and deploy it. Okay, we have it injected. Let's select the correct contract. It is called target example contract. This is the correct contract, and we have some parameters here so that we can specify them while we are deploying it. Okay, let's call it target. The symbol will be TGT for target, and the base URL. The base URL will be the following. Just a second, let me grab it from one place here. You can actually grab the potential option from the ENV example that resides in the same repository where the contracts and the code reside. Okay, so let's deploy the contract. This is a transaction on Polygon testnet, Mumbai. That's where we're assigning it. Let's wait a little bit. And once we see confirmation here in the terminal window, yes, we have it here. And here is the address of the target contract. Okay, so here are some things that we will have to do in order to be able to continue. So first of all, of course, let's check that this is our contract. The contract's name is target, and the symbol name is TGT, just like we specified. Total supply should be 0. We don't have any NFTs yet. And what else can we check? Well, this is my account. I deployed it from here. And we can also check base URI. This is the one that we gave it. All right. Okay, so everything is fine. Okay, the next step is we have to provide the minter role to the bridge smart contract in order to allow it to mint wrapped NFTs on the target chain. So here is the function, the first one, add minter. And all we have to do is to provide the address of the minter smart contract. But the question is, where can we get this minter smart contract? And we can get it from here. Let's go again to GitHub of XP.network. And here we have the library, which is called XP.js. This is our bridge library that allows you to use the functionality without the UI. Let's go to source, factory, factories. Okay, here's the file where all the smart contract addresses reside. Here you have to be careful because the chain factories are divided into testnet, which starts somewhere closer to the beginning of the file, and mainnet. So depending on where you're deploying your contracts, make sure that you choose the minter smart contracts or the bridge smart contracts from the proper object. Right now, we are working with the testnet, so we'll have to stick with the testnet chain factory. How do we know which contract we need? There are plenty of contract addresses here. So the answer is you have to look by the mint address. This is the original name of our contract. And here, every object here represents one blockchain. And we've minted the target contract on Polygon, on Mumbai. So we have to look for Polygon params. And the mint address is exactly the one that we are looking for. So we'll copy it from here. We'll go to Remix. We'll place this address here and we'll click transact. Let's confirm it in the wallet. And let's wait a little bit for this transaction to be added to the block. And there we go. The transaction is added to the block. Now we can verify that this bridge smart contract address is now the minter. We have a special function that is called isMinter. We can provide the same address here and ask the blockchain whether the contract knows that this other bridge smart contract is the minter, and we get true, which means we've done everything properly. We're now ready to go. The next step for us would be, we would have to provide the addresses of both the contracts and the chains to the team of XP.network. But since I'm already on the team, I can do it myself. So I will have to do the following. I will have to add both the contracts to the mapping inside the bridge. So I will take the address of this contract, and I know that it was deployed on BSC, and I will add it as the contract on the chain of departure. And I will copy this address, and this will be the contract on the chain of destination. And I will send a request to our API. And then I'll do the following. I'll again take this address, and I'll check myself that if I query this API by this address, I will get the proper target smart contract address. Okay, I see that the target smart contract address ends with E6B7, and in the check I see that it is E6B7. Okay, that's exactly my address, which means I've properly added the contracts to the mapping. The next stage would be, I would open a new window of Visual Studio Code. This is our favorite code editor. And I will go to the repository. On the desktop, I've created a testing folder. And here I cloned this contract interfaces from the GitHub of XP.network. And let's open it here, like so. Okay, and we can see that everything is already installed. We have node modules, we have yarn log with all the files here. We have the package.json and env example. So the next step here would be to provide all the necessary variables for the project here. Again, we have original contract and target contract. Those are the addresses of the contracts that we just deployed. So we can go back to Remix. And this is the original contract. Let's copy its address and place it here. Let's go to the target smart contract and place its address here. Okay, I've already populated the contract name and ticker and NFT prefix in advance. It's already part of the repository, so you don't have to bother about it. We can also provide the target address of the receiver of the NFT on the other side. We can grab our own address from MetaMask, and the secret key, well, I'll provide it later. I will not show you my secret key. And pretty much we're ready to go, except that the secret key should be provided. Let me pause the recording. And I will provide the secret key there. Okay, I've added the secret key of my account, and now we are pretty much ready to go. Well, in order to understand what's going on, first of all, to the second, we have to remove the .example from the name of this file, otherwise it won't work. Should do it like this. Now it's a proper env file, we can close it. And the main file that we're going to need here is the index. Okay. So let's see what happens inside this file. Here are some imports from XP.network library. And some functions that I've prepared for you here to do some boilerplate work. We are creating all the constants from the environment variables that we just populated. The only things that we will have to change are the NFT number, the NFT ID. It will start from 0. And the URIs, if you want to change them every time you mint a new NFT. This will create a selected NFT object for us to transfer from one chain to another. So every time we send an NFT and we mint a new one, we will have to increment this number by 1. Okay, here we have 3 flags that are very convenient. We don't have to rewrite or comment or uncomment the code. We can just set the flags from false to true or from true to false in order to run this or that part of the code. So let's do the following. The first thing we want to do is we want to mint an NFT on BSC. And we'll do it like this. We'll change this to true. Okay, and this will launch this part of the code. The minting function resides in the functions file here. It will be called once we launch this file. To launch the file, we have to go to the terminal and run yarn start. Okay, so let's do that. And this is supposed to mint an NFT on BSC in the contract that we just deployed. First of all, it compiles the repository. It turns our TypeScript into JavaScript. And now we are waiting for an NFT to be minted on BSC. As we can see, we have successful NFT minting on BSC. This is our method. This is our transaction hash. If we want, what we can do is we can go to the browser and open the Explorer of BSC on testnet. I already done that. Let's just refresh the browser, and we can see that 30 seconds ago, we minted an NFT. Okay, so this is the transaction. It is successful. We have a new NFT minted. And let's see where it was minted. The token ID of this NFT is 0. And it was minted in the original contract example, or OCE. This is exactly what we just created and deployed. Okay, let's go back to all the transactions to be able to see the big picture. And let's uncomment. Let's turn shell mint to false because we don't want to mint an NFT anymore. We already know that the ID of this NFT is 0. So we have the NFT counter set to 0, and we're good to go. The next step before sending an NFT is approval. Approval makes the bridge smart contract the operator of this asset. This is a security measure in most NFT standards. So let's turn this to true, and let's run the same script again. It is another transaction. So we have to wait a little bit for the blockchain to respond. Fortunately, we're doing it on the testnets. Testnets usually respond faster than the mainnets, and there we go. It's approved, and here's the transaction. We can again go back to the chain explorer, and we can see that the approved transaction has just occurred 8 seconds ago, which means we're good to go with the transfer. Let's again turn shell approve to false because we don't want to waste our time on that anymore. And let's turn shell transfer to true. This will call the transfer function. And if we set everything properly, we will send an NFT from BSC testnet to Polygon testnet, and it should arrive to the target smart contract that we deployed there. Okay, so we have everything set up properly. Let's run the script again. This time it will take a bit longer because this is a more complicated transaction. This is going through real testnet explorers of the bridge. It says transferring NFTs. If we did everything correctly, it says minting with, and this minting with should be the address of our smart contract on Polygon. And it is E6B7. Remember, this is the one that we deployed here. We can also go to Polygon and see that. Let's refresh the Explorer. Yeah. So 10 minutes ago, we deployed a contract, right? And let's see what contract we deployed. It is E6B7, right? And let's see what we see here. Okay, so we have a transaction. There are no errors. It means everything worked fine. So E6B7, this is the address of our smart contract. So this is where it should arrive. Let me quickly check the logs of the validators. And the logs of the validators are fine. They look good. And let's go to Polygon. Well, first we can actually go to BSC. We can check that the transaction, this is the transfer transaction. Okay, let's get inside the transaction and we see that it succeeded here on BSC. Let's do the same on Polygon. The last transaction should be here, I guess. Yes, 1 minute ago. We see that from address 0 to our address, one NFT was created. This is the ID of this NFT, and the name of the contract is target, or TGT, exactly like we set it when we deployed it, which means our NFT successfully arrived to the target contract with our custom collection name. We could add any custom logic that we wanted. And this is exactly what we wanted to achieve in our today's demonstration. So this is the end of that demonstration. Thanks for joining us, and stay tuned and see you in the next videos.